So we are in 4.2, ready, set, go, and we're going to do number 17. And the directions are use the given root to find the remaining roots. Then write an equivalent form of the function. And so this is leftovers from last unit, but it actually helps us in this unit, and you'll see why maybe in a lesson or two. So they gave you a root, which is 8. And then they gave you the function and they said, find the remaining roots and then write the equivalent form of the function. So the first thing that I'm going to do is, if this is the root, what is his factor? What is its factor? So its factor is x minus 8. Right? Its factor is x minus 8. And so this is like this is one of the factors. They're asking you to find the rest of the factors. Now, if you look, the fundamental theorem of algebra tells us that because 3 is the highest degree, I should be looking for 1, 2, 3 factors. So I only need to really find 2 more factors and then I'm done. Okay. So then you're like, okay, well, how do I find the rest of the factors? Well, if this is one of the factors, that means I could divide out that factor and then play with the leftovers of that factor. So wait, what, Ms. Johnson? So I'm going to take my polynomial. So x cubed minus 14x squared plus 57x minus 72. And I want you to divide out x minus 8. So if you remember when we were doing this division problem, we were just playing with like x times what gives me x cubed, and then you would, it's like long division. So remember those kind of steps. So the very first thing I say is x times what gives me x cubed, and you say, oh, Ms. Johnson, it's x squared. And just like long division, you line it up with, like terms. So I put them on top of x squared. And so x squared times x is x cubed. And x squared times negative 8 is negative 8x squared, right? And then I go through and I subtract, because that's the next step, right? Oops, sorry. I should have used that same color. Hold on. And then I go through and I subtract. But then Miss Johnson doesn't like subtracting because she forgets, and then all of a sudden everything's wrong. So she changes it to adding the opposite. So I add the opposite. So I change that x cubed to negative x cubed. I change that negative 8x squared to positive 8x squared. And then so now all I'm doing is I'm going to add. So notice these two, x cubed minus x cubed is 0. That means, yay, I did it right? And then I continue. So negative 14x squared plus 8x squared, that's negative 6x squared. And I just like to bring everything down because, I don't know, I don't want to forget anybody up there. So I just bring everybody down. Okay. So then I just do the same. I repeat the same steps. So x times what gives me negative 6x squared. And you guys say, oh, Ms. Johnson, that's minus 6x. And then I go, okay, negative 6x times x, that's negative 6x squared. Negative 6x times negative 8 is negative 48x. Is that right? Negative 6x times, oh, it's positive, Ms. Johnson. So it's positive 8x, positive 48x. And then I'm going to subtract. But then Ms. Johnson, she doesn't like to subtract because she forgets. So then she changes everybody's sign. So she like crosses off that positive, the plus, and puts in minus. So negative 6x squared plus 6x squared is 0. So then I'm happy because I did that right. So 57x minus 48x is 9x. That's what I think it is. So it's 9x minus 72, right? Okay. Then I just continue. So x times what gives me 9x? That's plus 9. So 9 times x is 9x. 9 times negative 8 is minus 72. And then I'm going to subtract, which in reality, I'm going to add everybody's opposite. And notice this is 0. I shouldn't be like surprised, like, oh oh my gosh, it's a 0. I shouldn't be surprised because they told me that this is a root. And if this is a root, then this is a factor. And if this is a factor, then my, I was going to say my denominator, my remainder is 0. My remainder is 0. Give me a second. Okay, so we're back. So we found that when we divide out by the factor to our polynomial, we get this leftover guy here. So I want you to think kind of like this is what we basically did. I said, hey, I need you to factor the number 60. Okay. And you're like, oh, okay. And you're like, oh, wait, I know that 6 is a factor of 60. So you're like, okay, that means 10 is a factor of 60. So then you take 10 and now you're going to try to break 10 up into its parts in order to find the rest of the factors. Does that make sense? So that's what I'm going to do right now. I'm going to factor x squared minus 6x plus 9. And some of you already remembered how to do that. So x squared minus 6x plus 9. You're thinking of, and I'll use the box, even though for the most part, most of you probably can do this in your head. I'm just going to show you just in case. I'm thinking of two numbers that multiply to get to 9, but add to get to -6. Uh-oh, I need to catch up. Hold on. My computer needs to catch up. There it goes. So I'm looking for two numbers that add to get to 9, but multiply to get to -6. So then you guys are thinking, you're thinking, and you're like, oh, wait, it's got to be -3 and -3. So everything in this box is really everything as that polynomial just broken up, right? X squared, 9, 9. And instead of writing -6x, I broke it into -3 and -3 so that I can factor it. Okay, so here I go factoring. I say, hey, what's the biggest thing I could take out of x squared and -3x? And you say x, and I'm like, yep. So then we play who's missing. X times what gives me x squared? It's x. X times what gives me -3x? It's -3. X times what gives me -3x? It's -3. So there's your two factors. And you're like, Ms. Johnson, they're the same. Do you want me to write them together? Do you want me to write them separately? You get to choose. So here it is factored. So it told me to use the root to find the remaining roots. Ooh, I did not find the roots yet. I only found the factors. And then write the equivalent form of the function. So here's the equivalent form of the function. If here's the factors, what are the roots, right? So then my roots are x is equal to 8, 3, and 3. So, hey, Ms. Johnson, do you really want us to write 3 twice? No, you don't have to. I just wrote it just so that you didn't ask, hey, Ms. Johnson, where'd that other one go? So usually this, when we have a double root like this, like 3 and 3, it means that we have a double root, number one, but it means something special in the graph, which I would like to share with you. So first thing I'm going to do is I'm going to check my answer. And the way I check my answer is I plug this in. So I go x cubed, let's see, minus 14x squared plus 57x minus 72. So there's my picture. I don't know if you guys can see my picture. Oops. There's my picture. You can kind of see it, right? So something interesting happens at that double root of 3. You see that? Something very interesting happens. What I like to do is I like to pretend that I have like a little camera and I take a small picture. I zoom in all the way here. And that zoomed in picture looks like a parabola, which makes sense, which is why it's x minus 3 quantity squared, right? X minus 3 times x minus 3, or it's a double root. So at that double root, it approaches the x-axis, touches it, and then runs away, right? Because that's what happens in terms of x squared. So the way I check my answer is I plug in the factored form. So x minus 8, x minus 3, x minus 3. And I could have put squared if I wanted to, but I didn't. So if you notice the blue guy is on top of the red guy, that means that I did it right. I also noticed that my roots are right here at 3 and at 8, which is exactly what I said. So that's how I use the answer to check, this is how I use the calculator to check my answer. Hey, Ms. Johnson, couldn't I have just done that from the beginning and pulled off that information? Absolutely. But remember, Ms. Johnson, she looks for work like this in order to validate your reasoning, right? All right, so very good. Hope that makes sense. Have a great day.